Everything that exists is a chemical. Look for something around you and check if you won't find that it is a chemical. Indeed, chemistry is done with an intention, but we shouldn't forget that it has consequences. Those beginning newspaper clips, they show when chemistry hits, when it's done without an intention of preservation of life, nature, and the environment, catastrophe follows. The consequences include contaminated water, expenditure of natural resources, use of chemicals to maximize profit, accumulation of plastic waste, chemical plant accidents, like those we have seen, the processes and materials that cause climate change. We have seen many. So this is the risk of taking on chemistry. But we shouldn't forget why chemistry is done and the progress, the benefit it comes with. It has prolonged the life expectancy. It has helped decrease the diseases that were a problem long time ago, like diarrhea. It has also helped in the food production due to the different methods, substances, fertilizers, and all that are used to help. But these benefits sometimes come at a cost. What was the design statement for today's chemical sector? Someone might ask, why do these people design? And the chemicals, why were they designed? And what was the main intention? During the design of the chemical sector today, functional performance was paramount. Giving an example of the oil industry, we are seeing after resource generation, production, use, end of life. And these are then thrown in the landfill, sometimes incineration, and then left over to the environment. Whatever is being done here, you'll find that process is linear. That from the generation of raw materials or from extracting them from their natural state to the end of life, whereby we are not at any point thinking about where will we get the next resources for our generation, leaving the resources exploited. Besides the linearity of the production process in the chemical industry today, we have also the acceptance of the use of toxic materials and substances in order to serve a function. This goes back to what I told you today, that during this time, we are saying that function is the absolute and paramount at all costs. So to a point that even human health is given or traded in order to get the function. Many times you'll see in the newspaper and different research pointing out that day by day they are finding new toxic chemicals in the umbilical cords of the children who are born today. This is really concerning. To add on, another evil today that is practiced, and it is of the mind, whereby people think that out of sight, out of mind. So they will use anything, any product, whether it will hurt the environment, but after they will throw it and they forget about it, not knowing how it will affect the environment. Besides the risk, there's also poor management of the inherent hazards, leading to fatal and chemical exposures that will result to death, to environment disturbances, and all this. All these accidents happen, and the immediate effect would be death of animals, organisms, and people themselves. But there is a longer effect of the chemical exposure that will inhibit the survival of life in these places. What is a risk? We shouldn't forget that a risk is a probability function, and it has two variables in it. One is a hazard. So probability is a function of a hazard and exposure. For example, I'm using an acid to illustrate my explanation. A hazard is it being corrosive. Now the exposure is if by a mistake acid falls on my hand. So since it is corrosive, or it will burn, it will bring that hazard on me, it will burn my fingers or my hands. But imagine in a scenario whereby hazard is removed. So it doesn't matter if there is exposure, there will not be risk, because the risk is mainly inherent of the hazard. Exposure will not be an issue if it has no hazard. There are many hazards, different types. We have carcinogenicity, we have aquatic toxicity, explosivity, many hazards of the environment toxic hazard. We have physical hazards, human toxic hazard, name them, many, and they are diverse. But if these are well handled, we will indeed control the risk against the environment, the risks to human health, and risks to a stable climate. With this background, it all leads us to a new paradigm of chemistry. Chemistry is meant to serve a purpose. It has an intention. Now, I introduce to you what we call green chemistry. Green chemistry is the design of products and processes that reduce or eliminate the use or generation of toxic or hazardous substances. So with this, we are trying to curb the effects, the risks that are involved in chemistry that was done as the conventional way, whereby we have a thinking to control the hazards before even our products and processes are in place. With this, we are seeing that design is really intentional. We are intentional even the development of this product. We are seeing that hazard and the hazardous substances are controlled by minimizing exposure. That's why you're given protective equipment, whereby they want to limit the exposure of these hazardous substances. Now, green chemistry brings in a different way of doing things, whereby we are using the intentional designing to master these products in that they will not have any issue with you, where we are limiting and eliminating the hazard from being even there, to a point that when you're exposed to these products, you have no worry about this hazard reaching onto you. In order to achieve this goal, we have to elevate the sustainability criteria to the level of function, not only considering function at the cost of even life, whereby we have to think about the renewable materials, the non-toxic and biodegradable aspects, then also function, because at the end of the day, we want this product to serve its function. Therefore, green chemistry calls for a change of mindset, whereby our perspective as consumers, producers of these products, we should change our perspective. We should consider that hazard is a flaw in the design procedure, and we should arrest it during our designing process. We should indeed move from the status quo of just fulfilling a function. But again, we have to consider that whatever we are doing to receive this function, it shouldn't come with risk. Imagine us borrowing from nature. Nature gives a lot of examples from which we can learn and copy. In the next video, we are going to learn about how can this green chemistry paradigm or shift in thinking be achieved. Can we copy from nature? Those are some of the episodes that will come along this playlist. So if you don't want to miss them, kindly subscribe, like, share, comment.